Write down the coordinates of B. B is the center of a circle with an equation x plus 1 squared plus y minus 1 squared is equals to 20. We want the coordinates of B, the center of that circle. So B will have an x value which is minus 1 and a y value which is equals to 1, right? Because the general form of this equation of the circle that we're using goes as follows: x minus a squared plus y minus b squared is equals to r squared, where a is the x value and b is the y value at the center of the circle. So it will be easy to see here that for you to get x plus 1, a needs to have been minus 1, and for you to get y minus 1, y needs to be equals to 1. Hence, we are seeing that the coordinates of B is minus 1 and 1. That is 4.1. Let's take a look at 4.2. So 4.2 show that AC is equals to square root of 5. What even is AC? Let's go and take a look. So we have AC, right? And then B is the center. We have the coordinates of the center. We know that that is, let me just edit that there, minus 1 and 1. We know the radius squared. The radius squared is 20. So it means that BA should be square root of 20. So we have square root of 20 right there. So we should have BC in some form or another. Let me go ahead and find out and see what is happening here. Right, so in the diagram, the equation of the center centered at B, of the circle centered at B, is given by, that is the equation I've been using. DF is a tangent to the circle at A with D and F the x and y intercepts respectively. So D is the x-intercept and F is the y-intercept, right? C is a point on DF. So we are given the coordinates of C. We have minus 1 and 6. Yeah, it is a point on DF with BC being parallel to the y-axis. So BC is parallel to the y-axis, right? So we have BC being parallel to the y-axis. And then what else? CBA is theta, that angle given to us there. It is equals to ADO, this angle there. They have the same sign already, so we can just leave them. I think it will be easy to see. So we are looking for AC. This is what we are interested in, right? We have AB, and then we're given the coordinates of B and C. So I think we can use theorem of Pythagoras here. Let me show you why. BA is a radius, DF is a tangent. So radius is perpendicular to the tangent. So it means that here we have an angle of 90 degrees. If we have an angle of 90 degrees, we can use a theorem of Pythagoras, obviously. So we just need to calculate the length of CB. We just need to calculate the length of CB. Obviously, we can use the distance formula, but CB is a straight line going up. It should be easy to actually deduce the length of CB without using the distance formula. But for the faint-hearted ones, CB is equals to the square root of y2 minus y1 squared plus x2 minus x1 squared, right? This is equals to the square root of, so let's take C as our second point. So we're going to have 6 minus 1 squared plus minus 1 minus 1. So minus 1 plus 1, that is just 0, right? So CB, this is equals to, and then 6 minus 1, that is 5. So we have 5 squared, which is 25. So square root of 25. So the distance is always positive, right? Because distance is a scalar and not a vector. So already we can see that CB should be equals to 5 units. So there we go. We have CB, which is our hypotenuse, and we have AB. We are looking for AC. So CB squared should be equals to AB squared plus AC squared. CB squared. So that is 5 squared being equals to AB squared. So that is square root of 20 squared. And then plus AC squared, which is what we're looking for ultimately. So this is 25. And then square root of 20 squared, this is 20 plus AC squared. So AC squared is equals to 25 minus 20, which is 5. We take square roots on both sides. AC is equals to the square root of 5. So there we go. That is AC. AC is equals to the square root of 5. This is 4.2. Let's go ahead and take a look at 4.3. So 4.3, write down the value of tan theta. Write down the value of tan theta. So because we have already deduced that this is a right angle triangle, we can use trig ratios. So tan of theta is equals to the y over the x. So this is our, okay, I'm trying to rotate. I was trying to rotate this diagram, but it seems impossible to do that. Okay, but then this is our theta. The adjacent, which is going to be our x, is square root of 20. And the opposite, which is going to be our y, is AC. And we know that AC is square root of 5. So we're going to have tan of theta being equals to the opposite, which is going to be our y in this case, square root of 5, divided by the x, the adjacent, which is AB. This is square root of 20. Right. So tan of theta is going to be equals to 1 over 2. It's going to be equals to 1 over 2. Right. Yeah, when you look at square root of 5 divided by square root of 20, you don't really expect 1 over 2. You don't actually expect 1 over 2. But that's what we end up with there. Right. So that is 4.3, pretty much straightforward, really, not really complicated. Let's go ahead and take a look at 4.4. So 4.4, let's take a look. What is the equation saying? So in 4.4, show that the equation of AB is given by y is equals to minus 2x minus 1. What's the mark allocation? 3 marks. So shouldn't be too bad. AB, we're looking for the equation of AB. The equation of AB. Okay. Is there anything we can use from the previous equation to find the equation of AB in the equation that follows? Is there anything we can use from that equation? Let's take a look. Let me just erase some of these things for the sake of clarity and only draw the things that are relevant to our equation. So we have the coordinates of B, we have the coordinates of C. Let me just put that there. I can just put it here. C is minus 1 and 6. Do we have the coordinates of D? Do we have the coordinates of D? Because if I have the coordinates of D, I can calculate the gradient of DF, and then multiplied by the gradient of AB should give me minus 1, because they are perpendicular to each other, right? The radius is perpendicular to the tangent. And actually I can, because look at this. This angle here is theta, right? This angle here is also theta. And then in the previous equation 4.3, we said that tan of theta is equals to 1 over 2. So tan of theta is equals to the gradient, right? The gradient is equals to 1 over 2. So the gradient of this line DF is actually 1 over 2, because tan of theta is equals to 1 over 2, and that is the gradient. So we have the gradient of DF, right? We have the gradient of DF. Yeah. I'm just appreciating the link from 4.3 to 4.4, that in doing 4.3, I had no idea that it is related to DF, but look at us now. So the gradient of DF is 1 over 2. So as I was saying, is that if we have the gradient of df, therefore we can say the gradient of df multiplied by the gradient of ab is -1. Df is f, ab is what we're interested in, and this is equals to -1. So the gradient of ab is equals to -2. So y is equals to -2x plus c. Yeah, that is the equation of line AB. We can substitute B in order to find the value of C. The y value is 1, okay, and the x value is -1 at B, and then this is plus C. So 1 is equals to 2 plus C minus 1 is equals to C. So take a look at that. We are done with 4.4. We just need to conclude and say y is equals to -2x minus 1. So please don't make a mistake and leave it like that. You need to substitute back. So that is 4.4. We've showed exactly what we were required to show. Let's take a look at 4.5 and see what we are dealing with. So 4.5, determine the coordinates of A. So 4.5, we are looking for the coordinates of A. We know fully well that we have x and we have y. Let's take a look at our diagram. So it's A. A is right here at the circumference of our circle. Yeah, it's on the circumference of the circle. So what is special about A? Well, using what we used when we moved from 4.3 to 4.4, let's see if we can sort of do the same thing here. We have the equation right here. This is the equation for AB. We have this equation for AB, and then we also have the equation of the circle. So can we use those two equations simultaneously to find the coordinates of A? Take a look at this. Okay, we know that A, it has coordinates x and y, obviously, right? Because that's our coordinates, that's the system we use. So in place of x, we can substitute x, but in place of y, we can actually put -2x minus 1. So here we can have -2x minus 1. You'll see why I'm doing that in a second, if it has not clicked yet. But then if you've been watching the previous videos, we have came across a problem where we needed to do something like this. So these are the coordinates of A. Why are we writing A in that way? So that we can substitute it here in the equation of our circle, because we know that our circle is x plus 1 squared plus y minus 1 squared being equals to 20. So in place of x, we have x plus 1. We square that plus, and then in place of y, we have minus 2x minus 1, and then minus 1 once more, squared being equals to 20. Right. So what is x plus 1 squared? X squared plus 2x plus 1. And then let me just put this inside brackets for the sake of clarity. And then minus 2x minus 1. So we have minus, well, let me write it elsewhere and then solve it at the same time. Maybe let me just drag this here. So this here will give us, let me make that thicker. Well, right, this here will give us minus 2x minus 2 squared. So when we solve that, minus 2x multiplied by minus 2x, that is 4x squared. Then minus 2x multiplied by minus 2 plus 4x, you multiply that by 2 plus 8x, and then plus 4. This is equals to 20. So let me just write it here. That is all equals to 20. So let's add the like terms. X squared plus 4x squared, that is 5x squared. 2x plus 8x, that is 10x. Plus 1 plus 5 plus 4 plus 5. This is equals to 20. So 5x squared plus 10x minus 15 is equals to 0. Obviously we can divide everything by 5. We get x squared plus 2x minus 3 being equals to 0. Can we easily factorize this? 2 factors of minus 3, when we add we get plus 2. Okay, yes, we can. So x plus 3, x minus 1 is equals to 0. So x is equals to minus 3, or x is equals to 1. We're looking for the coordinates of A. Well, the coordinates of B, we have x being equals to minus 1. So the coordinate of A has to be less than minus 1. So this is not true. X is not equals to 1. X is equals to minus 3. So if x is equals to minus 3, y is equals to minus 2. What is that equation? Minus 2x. So minus 3 minus 1. So this is 5, right? So the coordinates of A, x is minus 3, y is 5. There we go. That is 4.5. Let's do 4.6. Let's do 4.6. 6 bucks. Should be interesting. Calculate the ratio of the area of triangle ABC and the area of triangle ODF. Okay, we are looking for the ratio. Yeah, okay, so let's see what we can do here. Simplify your answer. Okay, let me just highlight ADF first. Let me just highlight ADF. So I'm erasing all this junk. I'm only leaving the things that I want there. Not ADF. Oh, ODF, right? And ABC. Yeah, because ADF would be a line. So ABC, let me highlight that triangle. ABC. It seems like it should be quite easy to find the area of ABC. Yeah, I mean, what don't we have with regards to that triangle? I think we have all the sides, and it's a right angle triangle. So we can just use area is equals to half base multiplied by height. We don't even have to use the area rule. Yeah. So let me just highlight this triangle. So there we go. That is ABC. That is ABC. Another triangle that we are interested in is ODF. It's ODF. So ODF. AB is square root of 20. Let me write some things here instead of messing up the sketch. AB, we know that it is equals to the square root of 20. We know that AC is equals to, we've calculated AC somewhere here. AC, yeah, so AB is our base and AC is our height. So AC is square root of 5. AC is square root of 5. Yeah, so we have the base, right? And we have the height. So the area of triangle ABC is equals to half base multiplied by height, which will be half. The base is, square root of 20. The order does not really matter because multiplication is commutative. The height is square root of 5. This is 5 units squared. So that is the area of triangle ABC. Okay, so let's erase triangle ABC and worry about triangle ODF. Yeah, so we're no longer interested on this one because we have calculated it. We are only worried about ODF. So let's take a look at ODF. Yeah, how can we dissect ODF? Obviously, the first thing to realize here is that we actually have the coordinates of O as it is the center. So we have 0, 0 there. Obviously, here we have an angle of 90. It seems like we just need OD and OF. If we get OD and OF, we shall be able to calculate the size of that, the area of that triangle using half base multiplied by height. So how do we therefore calculate D and F? Well, we have the equation of AB, right? The line AB. And we have the gradient of DF also. And then we have the coordinates of A at this point, because we know that A has coordinates -3 and 5. And we know that tan of theta is equals to 1/2. So this tells us that the equation of the line DF is y is equals to a half x plus c. So if I substitute A, I shall get the equation of that line. And after I get the equation of that line, I will be able to find D, and I will be able to find F. And in finding D and F, that will give me the distance of OD and the distance of OF with quite ease, because we have straight lines there. So the distance should be easy to calculate without the help of the distance formula, right? So when I substitute A, y is 5, and then this is a half, x is -3 plus c. So 5 is equals to -3/2 plus c. So c is equals to 5 plus 3/2. 3/2 is 1.5. So 5 plus 1.5 is 6.5, which we can write in the form 13/2. Yeah, that is way much better. So y is equals to a half x plus 13/2. So we can go ahead and find the coordinates of D and F, because they are our intercepts as we are told in the equation. So x-intercept, I will let y be equals to 0. So we get 0 being equals to a half x plus 13/2. So a half x is equals to -13/2. So x is equals to, minus 6.5 multiplied by 2. That should be 13, right? So x is 13. So the coordinates of D, we have x being -13 and y being 0. X is -13 here. So that's the coordinates of D. And then when we find the y-intercept by letting x be equals to 0, then we get y being equals to a half multiplied by 0 plus 13/2. This is 6.5. Well, let me just say 13/2. Small, I don't know why, but I prefer 13/2 over that. So the coordinates of F, we have x being 0 and y being 13/2. So obviously OF is equals to 13/2, right? And then OD is equals to 13 units. We don't have negative distance, because distance is a scalar and not a vector. So OF, OD, the area of ODF is going to be equals to the half base multiplied by height. So this is a half, the base is 13, the height is what, 13/2? 13/2. So we have 13/2. Well, let me just put that in my calculator and see what I get here. 169/4. I end up with 169/4. So that is the area of ODF. So area of ABC is to area of ODF. What did I get here? I got 5 units. Okay, so 5 is to 169/4. Yeah, that's not, that's not very well. Okay, let's multiply both sides by 4. Therefore, if we multiply both sides by 4, we get 20 is to 169. Yeah, this is easily digestible. Yeah, I think I'm happy with that. There we land.